Howdy there, Internet students. It's Mr. Hermanson again. This is lesson 12.3. We're going to talk about inscribed angles and find some theorems about those. Go ahead and read about this soccer problem here and see what you think about which is in the best position to get the goal. Well, here's the deal. If you figured this out, that's awesome. Let's create an angle here. This angle from player A, and then I'll change colors here. Player B's angle, and then one more different color, player C's angle. Well, since all of these players' angles intercept the same arc of the circle, all of their angles are the same. So angle A, angle B, angle C all equal the same. They're congruent. And the other thing we're going to find out is that they're actually half of the intercepted arc. So however many degrees this arc is right here, which comes from the center, the angle on the outside of the circle is half of that, which kind of makes sense, I guess. So here it is, theorem 1211, inscribed angle theorem. Measure of an inscribed angle is half the measure of its intercepted arc. Here's proof of that. Problem 1, we need to find values of A and B. Now A is part of this arc here, which, so I'm going to say this, A plus 56 is actually equal. Remember that this is going to be half of the intersected arc. So, so I'm going to double that. That's 104. And so A is equal to 104 minus 56, which is 48. And then B is just half of 56, which is 28. All right. And then let's look at this here. It says, what is the measure of angle A here? Well, since this arc is 180 degrees, we know that because this is the diameter goes through the center. That means that this angle right here, angle A, that is equal to 90. So any angle that you create using the diameter is a 90-degree angle because of this theorem. All right, you try one. See if you can find the measures of those four. All right, here's what I'm thinking. I hope that matches what you're thinking. One other thing, notice that it has to be true that angle A and angle C together would equal 180 degrees, right? Because their arcs cut off together 360, and so their measures are half of that. So the angles opposite each other like that would be supplementary. All right. So a couple corollaries to that. Two inscribed angles that intercept the same arc are congruent. We saw that in the soccer problem at the beginning. An angle inscribed in a semicircle is a right angle. We talked about that. And the opposite angles of a quadrilateral inscribed in a circle are supplementary, and we can easily prove that. All right, so now let's figure this out. So this is the center. So that means this angle is cutting off a 180-degree arc, but any angle inscribed using the diameter is a 90-degree angle. So the measure of angle 1 equals 90. Over here on this next problem, angle 2 cuts off this, which is the same as this 43-degree angle. So the measure of angle 2 is equal to the same thing because it's cutting off the same arc. Notice. All right. Why don't you try one of those, see if you can find the missing angle. Here's what I got. I hope we're agreeing on that. All right. So we're going to talk about one more thing here and follow this diagram. So if you move the angle around, remember that the angle is staying the same size. And in fact, we can move it all the way to the tangent and it'll remain the same size. So the angle created, angle formed by a tangent and a chord is half of the measure of the intercepted arc. So whatever this arc is, that angle would be half of that. All right. So in this diagram, AC is tangent to the circle. At B, if the measure of angle BED is 214, so this is 214, what is DBC? Well, since this is 214, we can do 360 minus 214 to get this part of the arc. Probably use a different color there. The blue arc. So subtract 214 and we get 144, 146. And then for this angle, then we're just going to divide that by 2 and we get 73. All right, why don't you try one of those? So this arc right here is going to be twice this 35, right? So that's 70. And that's going to be the same as x. So that's going to be 70. Well, I'm sorry about that. It's half of 70 because it's half of the intersected arc. So it's 35. So now this arc here is half, well not half, but it's part of the diameter. So if this is 70 to there, then this is 110 because they have to add up to 180. So y is going to be half of that 110, which is 55. All right. Looks like you're ready to try some practice problems. Good luck. We'll talk to you soon.